Hi everyone, welcome to Mosgyan. So in today's video, if you see one circuit is drawn here, which is a source follower circuit. Input is applied at gate, output is taken from source. So this is a common drain structure. Now in this question, it is asked to find out the pole and zero of this circuit. So one way of solving this question is by finding out the transfer function in Laplace domain, and then we can calculate from that transfer function pole location and zero also. But that is very hectic way of finding pole and zero. So instead of that, we will apply some other method to find out the pole and zero for the circuit. So let's start from the pole calculation. For pole calculation, what we will do, we will find out the R equivalent and C here for the circuit. Once we will have the tau, that is time constant for this circuit, which would be equal to R equivalent into C, we will find out the pole from this tau value. And similarly, for zero calculation, we will apply impedance divider concept here. So let's start from pole calculation. So for pole calculation, if you see only one capacitance given in this circuit, that means this is a single pole system. So C equivalent would be equal to C only. So that becomes easier for us. But we need to find out R equivalent for this circuit, because if you see source resistance is also given, one resistance is at gate also, and MOSFET is also there. So we need to find out the R equivalent for this circuit. If I have to calculate R equivalent for this circuit, what I can do, I can source all the DC sources and this capacitor will become open. So in that case, I can find the R equivalent for this circuit. So if I redraw the circuit for finding R equivalent, this is how the circuit will look like. It will have RS component. It will have this gate resistance also. But this capacitor will be now open. And this input will be grounded. Similarly, this will also be grounded. So if we see here, this resistance and this resistance will come into series because these two are shorted at ground, and along with these two resistance which are visible to us, there are two more resistance in this circuit. The first one is this gate resistance, which would be infinite, and the other impedance which will come here is when we start looking into the source of this MOSFET. So the MOSFET resistance or impedance would be equal to 1 upon Gm. So along with this R plus Rs, 1 upon Gm and infinite will be in parallel. So if I have to write R equivalent for this circuit, that would be equal to Rs plus R in series parallel to infinite, which is gate impedance, and parallel to 1 upon Gm. Now obviously in parallel, whatever quantity will be having the minimum value, that will dominate, and out of these three terms, we are considering the value of Rs and R is very high. So R equivalent would be equal to 1 upon Gm, right? Because 1 upon Gm would be minimum out of these three quantities. So this is the value of R equivalent which we have find out. Now time constant would be equal to R equivalent into C. R equivalent is 1 upon Gm and C is only one capacitor in the circuit, so that would be C. So this is the time constant we have calculated. Now if we have to find out pole frequency, so that would be equal to minus 1 upon tau. That means minus 1 upon C by Gm. So pole would be equal to minus Gm by C. So this is the answer of first part of this question where pole was asked. Now we need to find out the zero for this circuit. So again, as I mentioned before, we can find out pole and zero easily by finding transfer function of the circuit, but that is a very hectic way of finding and will take a lot of time. So rather than that, we are trying a different approach to find pole and zero. So for pole, we have calculated R equivalent and C and we have found out pole. Now we will do the analysis for zero also. For zero calculation, if we transform any circuit into impedance divider format, like for this circuit, let's say this is V out and this is V in. So if we transform this circuit into impedance divider network, then we can calculate the 0 for this circuit. Now we know 0 is that frequency at which your output becomes 0, right? So we need to transform this circuit into this kind of voltage divider and impedance divider circuit and need to find that frequency at which Vout becomes 0. Now Vout can become 0 in two conditions only. Either we short this from here to here. If we provide a short circuit path, Vout will become 0. That's the first condition. And the second condition is if we make this path as open circuit, so no current will flow from V to Vout, that means Vout will be sitting at 0, right? So let's first transform this circuit into this part and then we will analyze the 0 for this circuit. So we don't need to do anything. We can consider this part, let's call this at Z2, let's call this at Z1. So we can consider this particular portion RS as Z2 and this particular portion from R to C, this we can consider along with MOSFET as Z1. So if I compare this circuit with this one, so RS will become Z2. So I have replaced Z2 with RS. That means Vout can never become 0 through this path, right? Because RS will never provide a short circuit path to Vout to become 0. So that means if we have to find out 0, that means we have to calculate a frequency at which this impedance become open circuit so that there is no current from V into Vout and Vout becomes 0. So that would be our 0 value. So now we need to calculate Z1 here, because if you see, anyways, Z2 was only having one impedance as a resistance here, and resistance is not dependent on any S parameter, right? It's a non-frequency component, so this Vout can never go 0 through this resistor. That's why we are dependent on Z1 to find out the 0 value. So Z1, as I mentioned, will be having this component. If I redraw it further, if I simplify this further, Z1 part, so Z1 will have one component of capacitor along with this MOSFET, which is having a frequency component, right? This R will become negligible because it is not having any frequency component. And if I further simplify it, so this capacitor will become 1 upon SC in frequency domain. And if I start looking the impedance from source of this MOSFET, so it will have 1 upon GM component. So these two parameters will form Z1 for me, and these two are coming in parallel. So if I have to write Z1 value, that would be equal to 1 upon SC parallel with 1 upon GM. So we know if I have to find out the equivalent impedance for two parameters which are in parallel, so it will become R1 into R2 upon R1 R2. Simplifying it further, we will get 1 upon SC GM divided by GM plus SC and SCGM. So these two will get cancelled out, and ultimately Z1 we will get is equal to 1 upon SC plus GM. Now, as I mentioned before, 0 is that frequency at which Vout becomes 0 in presence of Vin. Now, in order to go Vout 0, this Z1 value should be equivalent to infinite. Then only this particular path will be like an open circuit in frequency domain, right? So that means we need to make this SC plus GM to go 0. Once it will go 0, then only Z1 will become infinite. 1 upon 0 will become infinite. So from here, if I have to calculate S value, that will come minus GM upon C. This is the value of 0 for this circuit, which we have calculated. So if you recall, our pole was also at minus GM upon C, and 0 is also coming at the same value. So this is how we have calculated the pole and 0 for this circuit. I hope you might have got to know about a different approach to find out pole and 0 for this kind of MOSFET circuit. If you found this video useful, please share with your friends, and if you haven't subscribed to the channel, please subscribe.